Assalamu alaikum students. We are here on lecture number 9 today, chapter number 2 still, application layer. We started from the top down approach in the layered architecture, TCP IP Internet Protocol Suite model, and we are discussing already the application layer. We discussed in the last lecture what are the application layer protocols which are being used on the application layer to provide different services to the users when they are using application programs, because application programs, they do need the services of the application layer protocols in order to provide services to the users. Okay, so the connection between the computers, how it should be managed. Pure point-to-point architecture, if we talk about, and we have a look here on the hosts. If this host wants to communicate with this host, it is a P2P connection between the two hosts, or if this laptop wants to communicate with this desktop computer. The first thing here is that no doubt the communication will not take place directly. Definitely the data will go through the intermediary hop and it will reach to the destination computer, but it will be considered as a point-to-point architecture, because no server will be involved in their communication. The communication will not go through a server. It will be a direct point-to-point communication. Okay. No always on server is needed, because if it is a client server communication, you do need the services of a server which should be kept on 24/7. Here we don't need, for pure point to point architecture in P2P communication, we don't need a server which should always be kept on, and arbitrary end systems directly communicate with each other. Any end systems can directly communicate with each other at any time. These are intermittently connected and change IP addresses, because irregularly, okay, we don't know at what time which peer will be connected to the internet, and it wants to have a connection with its another peer. So if he is getting internet service from its service provider, definitely it will be assigned an IP address by its service provider. And that IP address will might not be the static IP address. It can be dynamic IP address. So dynamic IP address can be changed. Okay, and it usually these are being assigned through the DHCP pool when a user gets a connection from its service provider. So it is highly scalable, but it is difficult to manage, because a server is not there to keep track of these peers over the internet, and they can have a direct point-to-point connection from one to another. Okay. For some examples of applications are there which are basically hybrid of both client server and P2P architecture. Client server we have looked in our last lecture. We have seen into an example of web client and a web server. Okay, web client computer was using a web browser, which is a web client application, and it communicated over the network with the web server. We took in the last lecture the example of Google Web Server. Here today we are talking about pure point-to-point connection and hybrid of both the client server and the point-to-point architecture. Skype is a very good example of this hybrid combination of both client server and point-to-point architecture. And the architecture of the Skype is such that first, when you log on to the Skype server, okay, by giving your login name and password, so your request will go to the Skype server, because your login name and password is stored on that server. So that server will authenticate your identity, and you will be granted access to the Skype server, okay, and you will be connected to the Skype server, and you will become online, okay. And you can see that in your list of buddies how many are already online, so that you can communicate with them. So any one of your friend who is right now online and you want to communicate with him, you click on his name, contact, and you will be through to him, okay. The further communication from this point onwards will be based on the point-to-point architecture. In that communication, the Skype server will no longer be involved in that communication further, okay. No doubt, in the initial phase for the authentication, there was a role of a Skype server in order to authenticate you and let you know that how many users, how many contacts in your contact lists are right now online, and how you can reach to them, what are their IP addresses. Definitely when you click on any one of the contact which is online right now in your buddy list, so definitely the message from your computer has to reach to its computer. So without its destination IP address, you can't send messages to that destination contact. So from where you will get it, this information is basically recorded on the Skype server. When you log on to the Skype server, okay, it will keep some of your credentials over the Skype server, which are helpful and which will be used for the further communication when the people who are logged on to the Skype server, they want to have a point-to-point communication with one another. So in the later phase, in the phase 2, when you click on any contact who is online already, so your connection will be through, and you will be given the IP address of that buddy, and he will be given your IP address, and the further communication will be point to point in the phase 2. Clear? So this is the architecture which is called a hybrid architecture for the application Skype. Okay. So voice over IP is a point to point application. Okay. Centralized server is there in the Skype in order to find the addresses of the remote parties, and in order to provide you the authentication when you log on to the Skype server. Client server connection, client to client connection is direct. Okay, it will not be through the server anymore. Once you are connected, once you know the exchange, the IP addresses of each other, okay, and you know that both the parties are online, and you contact each other and further communication, whether it is voice over IP communication or the text messages which are being exchanged, okay, it will be directly point to point. Instant messaging, chatting between two users, is also a point to point application. Centralized server will be there definitely to know the client presence and to detect its location, okay, and it is used for the user registrations. Okay, user registers their IP addresses with the central server when it comes online, and they are authenticated basically at the time of authentication when they give their username and password, and they log on to the Skype instant messaging server, for example MSN, Yahoo Messenger or Google Messenger, whatever messaging services, instant messaging services are used. Instant message IM is basically the application layer protocol which provides these services to these type of applications, and your IP will be recorded on the server in order to detect your location. User contacts the central server to find the IP address of the buddies, okay, with whom he or she wants to communicate, okay, and once you have the IP address, definitely the one who is having your IP address, he can directly communicate with you. Clear, guys? Now, who will be there at the back end of these applications who will be communicating over the network. These applications we are studying on the application layer. Okay, so processes will be there basically, which will be communicating at the back end. So programs are your passive entities. The content of the program are stored on the hard disk. Clear? Whereas they are not running, they are static. The code of a program is stored on a host on its hard disk or whatever storage media it is having. Okay. When you go click on the start, okay, program, Cisco Packet Tracer, okay, still it is a program. It is stored on the hard disk. It is not running. It is in the passive state. Content of a file, packet tracer, stored on the hard disk. When I click here, now the content of that program will come from hard disk to RAM and its execution will begin. Now that program will become a process. Now it is an active entity, and you can see its process here in the taskbar. If you go here, you can look here. This is the application, okay, Cisco Packet Tracer, and you can go to its process directly. So this is the Packet Tracer process, which has run by the user 611L6U1, and it is consuming this much memory, and this is the description, all details of this process. Currently right now on this computer, how many processes are running? 80 processes are running. Okay, so this is the Packet Tracer process. Okay, so now it is basically active because it is in this application is basically running. Look here, its status is running now. So that is why you can have a look on its process, which is running, and it is consuming the memory, and it is using the resources of the computer. For example, processor, main memory, RAM, okay, and it is in the state of execution. That is why it is called an active entity. Clear? So process, a program which is in the running state within a host computer, host machine, is called a process. You can call it the running state, mean it is in the active state. Within same host, two processes can communicate using inter-process communication, and this inter-process communication is for the sake of communication between two processes running on the same host, and it is defined by the operating system. The code for this inter-process communication is already being written in the operating system, and operating system is responsible to provide the communication between these two processes which are being run on the host. Okay. Processes on the different computer, if they are on different hosts, they can also communicate, but they will communicate by exchanging the messages in between them. Okay. But if they are on the same host, they will be using the inter-process communication facility. Okay. Definitely if it is a client-server architecture, as we have studied in our last lecture, if it is a client process, okay, it has to contact to the server process. So if the client process wants to contact to the server process, this process will definitely initiate the communication by sending a client request from client process on the client host, running on the client host, towards the server process running on the server computer, server host. And the server process will be on all the time, and it will be waiting to be contacted by the client process. How? Because client computer has sent a request from client computer, the client process has sent a request, which is the client request, and that request is being received by the server process on the server host, because that request has to be processed and the reply has to be sent back. The reply needs to be sent back to the client process, on the client computer. So this is basically the client server architecture. The client application, when you run it, it will be running at the back end a client process, okay, which will initiate or send a client request, and the client request will go towards the server computer, and on the server computer, the server application, when you run it, there will be a server process running 24/7 on the server, which will be waiting for the client request to be received by the server process in order to process those requests. Clear? And the architecture which we discussed in the last lecture, web client and web server architecture, that was a client server architecture that was working in the same way. Okay. Note, applications with point-to-point architecture have client process and server process both running on the same computer, because when it is sending a request, it will behave as a client process, okay, and when the other point peer is receiving a request and he is processing the request, he will behave as a server process, and when the other client peer is going to send a request, it will start behaving as a client process, and the first one who is going to receive now the client request, it will start behaving as a server process. So in peer-to-peer, both are there on both the peers. Both the processes are working on both the peers, both the computers. Clear? How the processes will on the transport layer, how the processes will interact with the computer and send or receive messages. The processes will use the socket communication. Okay, the processes will use the socket communication. Socket. Excuse me. Socket is basically required in order to provide a way of communication, or it is analogous to a door between the process on the transport layer and the protocol which is working on the transport layer. Okay, so the process, whatever process, whether it is a client process on the client computer or it is a server process on the server computer, the process will send or receive the messages to from its socket, because socket is like a door for the process in order to send the message through that door on that particular computer, or on that particular computer the process will receive a message through the socket on that particular computer. So socket is analogous to a door, similar like a door, okay, from where the process will push or pull the data, okay, on a particular computer. Sending process will pushes the message out from that door, okay. For example, this process, if it is a host or a server process and it is going to running on that computer, it is going to push a message, okay, through this socket into the TCP buffer, okay, so that it can be further transported by the network, sent to the network layer, and further it can be routed over the network. Sending process relies on the transport infrastructure basically, because that process is running on the transport layer on the other side of the door, which brings a message to the socket at the receiving process, and on the other side here it will come, okay, and the sending process will be waiting for the message, and when the message will come through the network into the buffer, the other side, on the other end, the socket will receive the message from the buffer and pass it to the process running on the other computer. If it is a client server architecture, definitely it will be a server socket. If it is a point-to-point architecture, it will be a client socket. Okay, so this area is controlled by the operating system. For example, the buffers which are here, and the socket which you have written, definitely for the communication you need a pair of socket, and pair of socket will definitely be have the IP concatenated with the port number. This will be client socket on one end. Okay, on the other end you do need same like this IP address concatenated with the port number. This will be a server socket. Okay, and this is the client socket. Okay, now on both sides you do need a combination of IP address of that computer and the port which is being assigned by the operating system of that client to that process, will concatenate it with the IP address of that computer, and it will become the client socket. Same like here, if it is a server process, it will be listening on a well-defined port number. Okay, and the well-defined port numbers are from 0 to 1024. These are for the well-defined services which are already being used on the over the network. Okay, and this port number will be concatenated with the IP address, and it will become a server socket. Now it is a pair of socket, client socket and server socket. When the pair will complete, then the communication can take place between the two computers, client and the server computer. Okay, so I was telling you the port numbers. Port numbers are well defined from 0 to 1024. For example, if it is a web server, okay, so it will be listening on port number 80. If it is a DNS server, it will be listening on port number 53. DNS, okay, web server, okay, web will be listening. If it is, for example, FTP, it will be using port number 20 and 21 for data and control. Okay, clear? If it is a mail service, SMTP, it will be using port number 25 for transfer the mails, and to receive the mails, it will be using POP3 will be using port number 110. Clear? So these are see, all the port numbers are within the range 0 to 1024. But if you are making your own application and you do need a port number, you can use port number greater than this until 65,536. So you can use port number within this range, in between this range, in order to make your own applications. Definitely you have to write a socket, okay, for your own software in order to communicate it over the network with a client server application. If you are making a application, you have to write its client and server and code. So definitely you have to assign the port numbers. You have to use the port number ranges. Okay, so if you want to assign, and on the other side, the operating system will handle these port numbers. Okay, these are the well-defined port numbers. If these services are running on your web server, any one of the services, if these are running on the server side computer, automatically these ports will be assigned by the server application. Okay, server application will be using these port numbers. But the question here is that how this client port will be assigned. Here the server applications are running, and they will take care of these port numbers, and they will assign the port numbers, concatenate the port number with the IP address of the server machine to create the server side socket. And who is responsible to create the client side socket? Definitely client computer will be having an IP address, but who will assign the client port to the client socket? The operating system on the client machine is responsible to assign the port number to the client, which should be greater than 1024. Okay, and you can ask a question over here that will the two clients be assigned the same port number? Yeah, different two clients can be assigned randomly the same port number, but their IP addresses will definitely be different. Okay, clear? So this is the initial introduction about the sockets and how the socket programming, how the socket communication basically will take place over the network. Okay. addressing the processes to receive the messages, process must have the identifier, and this identifier is called a combination of IP address concatenated with the port number, and this combination, this identifier is called basically a socket. And host device has a unique 32-bit IP address. We will discuss in the coming lectures the IP addressing in detail, subnetting, and fixed length subnet mask or variable length subnet mask in detail. And exercise is to use the IP config from the command prompt to get your IP address on the Windows operating system. For example, 32-bit IP address is assigned to every host in order to communicate it over the network. Now here we have to look on the network. We will be using different commands. So one of the command to get your on machine IP address is ipconfig. You have to use ipconfig command on the DOS prompt on your Windows computer to get your own IP address. So just go to the command prompt and type here ipconfig. Okay, so it will give you the local area connection. Here it will show you the IP address of your computer, 10.673.200. This is the IP address. This is the subnet mask, and this is the default gateway for this network. Clear? But if you are sitting on the Windows operating system, then this command will work. But if you are using Linux or the operating system of the iOS of the network devices, for example the routers, switches or firewalls, you have to use another command, ifconfig. So both the commands, functionality of both the commands is same, but these are for the different platforms. The Windows platform will be using ipconfig, and the Linux and the iOS platform of the networking devices will use the ifconfig command. Okay, so when you are sitting on those devices, don't use ipconfig, it will not work. You have to use ifconfig. So keep in mind, ipconfig and ifconfig command is used to retrieve the IP address of your host on which you are using this command, or you are giving this command. Clear? Question here is, does IP address of a host on which process runs is suffice for identifying the process? No. Answer is no. Only the IP address can't identify the process. No doubt IP address can identify the host computer. Okay? But on that host, if multiple applications are running, multiple processes will be running on that computer. So how you will make the difference between the different processes for different applications running on the same computer? So those processes will have different port numbers. Clear? Does the IP address of the host on which process runs will sufficient for the identification of the process? No. Many processes can run on the same computer. Now the question is this: you have to differentiate when you are going to send the data of for example 4 processes data you are going to send from one client computer, and this client computer is communicating with 4 different servers, for example. So the 4 sockets on the client computer will have the same IP address but different port numbers. And on the other side, on the server side, the 4 sockets will definitely have the 4 different IP addresses if these are the different servers, or if all the services, 4 services from these among the from this list are running on the same server, the 4 IP addresses in the server socket will be the same, but the port number should be different. If it is a web server, the port number will be 80. If it is a DNS server, the port number will be 53. If it is a data FTP, the port number will be 20. If it is telnet, the port number will be 23 for the telnet application. like this the communication will take place. We will have a look on to this in detail in the next lectures as well. So identifier include both the IP address and the port number, okay, which are associated with the processes which are running on the same host, okay, or the other host. So example, port number 80 is for the web server, HTTP server. Port number 25 is for the mail server. Clear? The application layer protocols basically define the type of the messages which are being exchanged between the host computers. For example, it could be request by one host, and the other host who is going to receive this request is responsible to send a response for that particular request. So it is a request response type of message exchange between the two computers. And the syntax of the message will indicate that what fields will be there in the message and how the fields are defined in that message for that particular message. Syntax will define the way you write the message, and semantic will let you know the meanings of the information contained in the fields. So message semantics will let you know the meanings of the information which is contained in the fields. Clear? Rules for when and how processes will send and respond to the messages. This is the rule, that how the process on one computer will send a message and how the process running on the other computer is going to receive and respond this process request. In the public domain, the protocols which are used, they are defined in the request for comments, okay, and from there once they are selected and become the standards, they will allow for the use, they are allowed to be used on the over the internet, and definitely the machines which will be using those protocols, they will be allowed for interoperability between them. Example, HTTP is a protocol which is used for the web service, used by the web client and the web server. SMTP is a protocol, simple mail transfer protocol, which is used by the web client and the email client and the email server. And HTTP is used by the web client and the web server. Hypertext transfer protocol. BitTorrent is another protocol to receive the files in chunks from different hosts over the internet in order to make the download fast. Proprietary protocol, for example, these are basically the public domain protocols which are already being defined in the RFCs, and these are being used for the interoperability of different hosts over the internet. These are the example of these public protocols, okay, and these services are already being defined, and their range of their port numbers is in between this range. Proprietary protocols, example the SkyP, PP stream, point-to-point stream, these are the protocols defined by the company. These are the proprietary protocols for those companies. These are also being used in their applications, in their own applications, who have invented these protocols. Clear? What transport services do an application need? For example, one application does need some service. So what service will be provided on the transport layer to a particular application? For the data loss, for the timing, for the throughput, for the security of the messages. What you will be basically, what type of applications we will be using over the internet? Data exchange, data messages, for example, emails or message exchange, okay, or web browsing, okay. This is the simple data which we are using, okay, or the file transfer, okay. So other than this, we will be using voice over the network, voice over IP, second service. Third type of service, we can use video. We can use video over the internet. So triple play, we call it data, voice and video. So data applications can afford a delay. Okay, data applications can afford a delay. No doubt data applications can afford the delay, but the voice or video application can't afford the delay. Okay, some applications, for example audio, can tolerate some loss of the data and they can afford the delay as well. Okay, but other applications, for example, if some of the voice packets are dropped or lost, you will miss that part of the speech. Okay, but for other applications, for example file transfer or telnet or email or web browsing, if some data is lost during the transportation, can you afford it? Is it possible that half of the email you can look on the screen and half of the email is lost? No. So email is a service, okay, which does need reliability. Can't afford data loss, but some applications can afford data loss. Okay, so the file transfer, telnet, email, web browsing, basically these are the type of services which require 100% reliable data delivery, data transfer. Timing, some applications, example internet telephony, interactive games, okay, they require very low delay. And why? To be effective during the communication, while playing the games, while watching the video. Okay, they can't afford delay. So their timing constraints are very tight, very limited. In the limited time, the packets for these type of applications have to be delivered to the destination because these applications can't afford delay. Clear? Throughput, some applications, example multimedia applications, require minimum amount of throughput to be effective. Other applications are elastic applications and make use of whatever throughput they get. It will not make a big difference, or it will not affect their performance in a in very worst way. Okay, so throughput means that how much data can be transferred in unit time. Okay, how much data can be transmitted in a unit time. So some application throughput constraint is very tight, and some applications are elastic whose throughput constraints are not very rigid. And security is an important service which is provided for the applications on the transport layer to encrypt the data and the integrity of the data. Okay, so these are basically the transport services which an application does need during communication. So transport service requirements of common applications, these are the name of the application in this column, and whether they can afford the data loss or they are tolerant to the data loss, what are the throughput requirement for these type of applications, and whether these applications are time sensitive or not. For example, file transfer can't afford data loss. No, these applications cannot afford data loss, and these are elastic. Even if these applications are not getting very good throughput, it does not matter. The maximum what can happen, instead of a file of 1 MB being downloaded in 5 seconds, it will take 7 or 8 seconds to download it. This will be the maximum difference in the throughput. Okay, time sensitive? No, not very time sensitive. Email cannot afford data loss. It is also elastic. There is no tight timing constraints. Web browsing cannot afford data loss. It is also elastic. Cannot afford, cannot very time sensitive. Real time audio video. This is now here where the difference will come. It is loss tolerant. Even some of the voice packet or some of the video frames, if they are lost, it will not be a big deal. Okay, and the throughput should be at least this much throughput should be there for real-time audio-video conferencing. Okay, 5 kilobits per second to 1 megabits per second for the audio, and for the video 10 kilobits per second to 5 megabits per second. 5 kilobits per second to 1 mbps, 10 kilobits per second to 5 mbps. These are the constraints for the throughput. Yeah, why? Because these applications are time sensitive. 100 milliseconds, 100 seconds or milliseconds. This should be the maximum timing delay which can be afforded by these applications. Stored audio video, yeah, can afford data loss. Same as above, requirement for the throughput, yeah. These applications are also, this application is also time sensitive, and few seconds it can afford as compared to the real time, because in real time it should be much quicker as compared to the stored audio video. Interactive games, they can also afford loss few kilobits, and also time sensitive, 100 seconds or milliseconds. Instant messaging, no, cannot afford data loss. Is it possible that can you afford that if you have written how are you Ahmad, and when you press enter on the other side Ahmad will receive how are Ahmad will be lost on the way somewhere? No, they can't afford. Elastic also, throughput can be variable. Sometime you will receive the message little bit late due to the congestion on the intermediate hops, and yes, these are bit sensitive but not very rigid, or very timing constraints are not very tight. Yes.
The email you data loss, you said no loss, but when you have the email and you have a photo not complete, it will be loss.
Photo not complete mean there is some problem in the attachment. Okay, this could be the reason. Okay, if you have attached the photo properly and you have the confirmation that your data is attached properly, so it will definitely, it should be delivered properly. Okay, so we stop here, and inshallah in the next lecture we will start from here. Thank you.